Understanding CPUs from first principles. Understanding how something works under the hood helps you imagine different ways to combine atomic pieces in new ways and configurations. Let's look at a simple CPU to understand how it works. We will use the 1974 CPU produced by Motorola called the MC6800. It's an 8-bit machine and contains the bare minimum to make a CPU work. It's a real device and was used in real computers. Early adopters, like hobbyists and early personal computer manufacturers, could afford to buy the MC6800 chip and use it in their circuits. They could intimately understand how it worked. The MC6800 CPU is an 8-bit machine, which means that its main registers are 8 bits wide, 1 byte each. The MC6800 has two main registers called accumulators A and B. It also has three 16-bit registers that are used for addressing memory. These registers are called the stack pointer, the program counter, and the index register, SP, PC, and X, respectively. It also has one 8-bit register called the CCR, condition code register, that contains flag bits that get set during interpretation of opcodes. A CPU is just an interpreter. It interprets opcodes. The interpreter runs very fast because it is implemented in raw hardware. The MC6800 uses about 4,000 transistors. The MC6800 CPU chip is connected to a bank of RAM memory chips. The CPU reads bytes from memory and interprets them as opcodes. It does this by placing 16 bits of address onto the address bus and firing the read line. Then it reads 8 bits from the data bus. In order to write a little program to add two numbers 37 and 23 together, we put the following bits in memory and tell the CPU to interpret them. Most programmers chunk the bits into 8 and use the hexadecimal number system to represent the bit patterns. Each 8 is called a byte. In hexadecimal, the bit pattern would be written as 5 two-digit bytes. In JavaScript notation, the prefix 0x is used to tell readers that the following two digits are in hexadecimal format. In 1974, Motorola chose to use the $sign instead of 0x to mean hexadecimal. Originally, such bit patterns were entered into memory using toggle switches on the front panel of computers. Later, with keyboards and teletypes, programs called assemblers were invented to allow humans to write these patterns as short mnemonics typed on QWERTY keyboards. In assembler, the above bit pattern would be written as shown on this slide.